Hello, everyone. I am Anurag, one of the co founders at TrueFoundry. And today I'm going to take you through how TrueFoundry helps you reduce your cloud costs for AI workloads. If we look at TrueFoundry, the structure of TrueFoundry is such that we have these clusters that are your own clusters that you can connect to your TrueFoundry UI or control plane. And then you can start deploying different services, models, jobs within it. Within this cluster, we have this concept of workspaces, which come with resource constraints, and we'll go deeper dive into it. Think of it like a group of deployments. And within this workspaces, we have deployments, and we support you to deploy different kind of things. For example, someone can start with a Jupyter notebook and or a Vscode that is hosted, and from there they can run their training job and log the metrics into one place. From there, someone can take the trained model and deploy it as a service or deploy the model directly. You can also deploy LLMs using our model catalog here. You can also deploy fine-tuned LLMs. In services, you can deploy async services, as well as you can deploy your own applications or Helm charts. So today what we will do is we'll go step by step and see at which areas and what kind of visibility we provide in the platform to help you actually control these costs at different levels. So before that, as at least what we have seen across our customers, we are at least 40% cheaper than what AWS SageMaker is or any other cloud providers' internal ML platforms are for deployment of LLM as well as ML applications or workloads. A large part of it comes because we run on top of Kubernetes, which kind of allows efficient allocation of workloads. We are able to further allow you to run spot instances across different levels that I talked about. And then there are a lot of things we do at the infra and the model optimization level where when it comes to the LLM side. So let's start first with the cluster. So at the cluster, we give you a functionality so that you get visibility of what kind of workloads are running on it in terms of capacity, whether it's a spot instance or an on-demand instance, and we show you the total savings. At the workspace level within each cluster, we give you a functionality to kind of set limits on the workspace and then be able to select which kind of instances are available. So let's quickly see that. So this is the view where you can connect your clusters, and it could be multi-cloud. So that allows you flexibility to also use GPUs across multiple clouds so as to reduce your costs. As you see, this is one of the examples of a cluster. And here you are able to see that how many nodes are running on-demand or spot instances. And this is where you see the total savings on the cost layer. So this at least gives a visibility and then allows you to see, okay, if that node that was running on spot could be on demand or vice versa. Now coming to workspaces, we give you an option to kind of select what kind of limits you want to set at the CPU, memory, storage level, and even what kind of instance families you want to allow. Say, for example, in a demo workspace, you might want to just allow CPUs and you might not want to allow GPUs. Or for some people who are working on non-GPU workloads, you might want to disable it so that they can never deploy something on GPUs. So this constraint at the workspace level allows you to kind of control costs. And we also showcase you the cost at each workspace level further using open cost. And this gives you a good estimate of what the costs across different workspaces are. And this could be across clouds, for example. So this is the first part of starting to understand where the cost savings start coming from. What this also enables, this multi-cloud cluster thing also enables, is when you have workloads that can be deployed across multiple clouds, you are able to support it through the system or move it from one place to another easily. The next part, let's come to the deployment of services. So in deployment of services, we allow you to use spot instances with the reliability that if you want, you can also have a fallback to on-demand. We also allow you to pause the services and enable auto scaling in a way that is time-based. So that, for example, if you are going on a Friday and you have a demo workspace, you can just switch off those services and put auto scaling. And we give you alerts as well. So let's go to one of the examples. This is a services page. And if you see, this is a service that's already paused. For me, it's very easy to pause any other service if I want, or I can also start a service that's already paused by clicking the resume. So this way, this is the first control at the developers to see, okay, which services I can not use and I'm not going to use, and I can pause it. The second is once a service is deployed, you get this metrics of over provisioning and under provisioning. And this applies for CPUs as well as even for GPUs. You can see that. So, for example, now I see that, okay, you know what, I have over provisioned my sources here. Then I can go back and always edit my form so as to go to a lower resources in terms of CPU, and just click redeploy, and it will redeploy my service at a lower CPU resource. Apart from providing this visibility and alert into over provisioning, under provisioning, what we also allow you to do is actually go ahead and deploy this on spot instances. So let's take an example of this service. Here you have CPU memory, but at the same time I can select, I can deploy it on GPU, but I can also select that I want the capacity type to be spot with a fallback to on demand. What it does is, if there is a spot instance, it will try to deploy on a spot instance. If the spot goes away, it will kind of get that trigger, and then it will bring up an on demand instance for running it. Apart from this selection of the capacity type, we also allow you to do auto scaling on a time based basis. So in ML, like request based second is the better auto scaling metric for things in prod. But at the same time, if you are running things on a demo environment and you know it's going to have no usability over certain periods of time, you can just switch this time based auto scaling. And what it ensures is, in this case, for example, every Monday to Friday, the replicas will run, and then from Friday night 9 p.m. it will kind of shut down till morning 9 a.m. So this way, a lot of costs that are being incurred can be saved. So this is on services. What we have also helped companies do is move from AMI to Docker easily, because all our deployments happen via Docker, and in that we have seen already cost savings of 30 to 40%. Apart from that, a number of companies have moved with us from EC2 machines to Kubernetes, again leading to cost savings because of the efficient allocation on Kubernetes. Now let's go to notebooks and Vscode. So one of the things we allow you to do is run your own hosted notebooks and Vscode on top of your EKS, AKS, GKE, or any other own private cluster. And in that, we support additional things, for example, shared volumes. So for example, if you have huge chunks of data that different people are using across notebooks, you can load it in volume and share that volume across different notebooks. Similarly, we have this functionality of pausing notebooks after certain minutes of inactivity. And even in notebooks, we allow you to use spot instances. So let's quickly see this. So this is an example of a notebook. I will probably start this notebook. And in the meantime, if I edit it, I can see that I have a functionality where I can stop it after certain minutes of inactivity. So this already allows that even if someone forgets, it will automatically shut down. It's persistent, so that way when you restart it, it will persist the environments and everything. At the same time, if I kind of go here, I can configure a volume and add a volume here from this. And once I add a volume, I can then call it in the notebook, and that way across different notebooks that I am running, I can have shared volumes which further increase help in reducing cost. And similar as in services, we have this functionality of using spot in notebooks as well. We don't recommend using spot if you are running large training workloads, but if it is small and you feel that it is fine, you can run spot. Another thing that is something you can do in your notebooks is you can start a notebook and run it on CPU if you are just going to use CPUs. And later on, if you want to run a GPU workload, you can just select it and you can just click submit and redeploy it. You don't have to kind of continue to keep a GPU resource up and running from the beginning to use it. So these are some of the things that allow you to kind of work with notebooks and help you kind of manage the resources effectively. Uh, we have like a blog in which we have done the benchmarking of our notebooks versus other cloud providers. And in terms of cost, if you look at it, being able to run the notebooks, this is a benchmarking across AWS, GCP, and Azure in terms of being able to run these notebooks either on demand or using the corresponding cloud managed provider. And you will see that there is a huge cost savings across the cloud providers. The deployments and fine-tuning for LLM models. We have gone a step further here to allow you to do deployments of LLMs in an optimal way with optimal configurations, including the right model servers. We also allow you to use the same spot instances in LLMs as well with a fallback on demand. We allow you to use async as well to do multi-region deployment so that you can lower the cost, and I'll go into this. And finally, when we go to fine-tuning, we support LoDa and QLoDa as well as other parameter-efficient fine-tuning. So let's quickly go into that. So this is our model catalog. So now if we go into a deploy, you as a as a team don't have to think about what kind of GPUs it will deploy on. So you can select any of them, and you can also select the right model server, for example, VLLM. And all the configurations that are optimal for its deployment is already configured, including CPU, memory, storage, as well as GPUs. If you want, you can also go ahead and say, I want to deploy on spot to further reduce this cost. Because of this, we have taken the hard work of doing all this testing, so you don't have to worry about it. And when you click submit, it will deploy it and deploy it in the right optimal manner. Similarly, when you do fine tuning, uh, we expose you different methods of fine tuning. For example, LoRa and QLoRa. As you can see here, if you do a full fine tuning, it will take 4 GPUs. But in LoRa and QLoRa, it will only take like one A100 GPU. So this way, you can actually do fine tuning at lower costs as well. And all the configurations are again created from the beginning for you, so that you don't have to worry about it, including CPU, memory, storage. You can always configure it and change it. But once you click submit, it will go ahead and it will create a fine-tuning job for you in this tab. And then you can trigger it. So for example, you see there are several jobs triggered on GPUs, and a lot of them are also LoRa, QLoRa. And if you wanted, you can actually trigger it from here and run the job. So these are additional things that we do to enable you to kind of fine-tune at a lower cost. Now, in terms of LLM deployments, one of the things that we do is allow you to deploy LLMs at scale. We have written this blog as well, where we support async deployments. And to enable async deployments, what we have provided is you can actually deploy an LLM in a way that you put a queue in front of the deployments, and then you can put the request to different regions across different clouds. So, for example, you had a RPS of 10, RPS that you wanted to handle. You can configure it in a way that you have a mix of on-demand instances and a mix of spot instances across different cloud providers. In a similar cloud provider, you can do the same thing across different regions so as to ensure reliability. And with that reliability, you have the optionality to now use more spot instances. And this enables you to serve LLMs at a large traffic with a good latency at much lower cost than running every instance on demand. This is something one of our clients has been running on, and we have been able to see huge traffics that they are running on with good reliability of more than 99.95%, and being able to do it at much lower costs for them as well. Apart from that, like for the LLMs, this is the benchmarking where we kind of did a benchmarking of deploying Falcon 40B on AWS EKS versus on SageMaker, and we were able to see 40% cost saving basis the usage of spot instances or a mix of on-demand and spot instances as well, versus the same cost for SageMaker being very high. We also did other benchmarking blocks for Llama 2 and similarly for Mistral, in which we have talked about the costs when you deploy it on an on-demand and spot as well, so as to give you more cost flexibility when you deploy these LLMs. Apart from this, so as we covered, like across deployment of services, training jobs, notebooks, as well as LLMs, we do a lot of things at the infra level for you to be running this at lower costs. We also do a lot of model level optimizations. And apart from this, there is obviously a lot of engineering time saving because of the way the system is built in an open-ended way. A lot of our clients, including few of the Fortune 100 companies, as well as some of the mid-market companies, have been using our system, and in some cases have replaced their internal SageMaker or cloud platforms to use our system on top of their own cloud, and they have seen 30 to 40% of cost savings using us. I'll also direct you to one of the blogs, the AI workload blog, in terms of whether it's bloating your cloud bill. So we have actually put all the best practices for the same here. And all of this automatically are inbuilt into the platform by default. So even if you use us, like all of this comes for free, apart from all the other things that I've talked about. You can also read the other reference blogs that I highlighted about Falcon 40B, but applies to other LLM models, notebooks, benchmarking on cloud, the model benchmarking blocks, and how to deploy LLMs at scale using our async deployment mechanism to do it at lower costs. This comes from the background of folks like including us and the team who have seen these platforms being built at really good companies, and we have tried to bake into the learnings to ensure that ML infra does not take up a lot of your cloud costs. Thank you so much.